Okay, so yesterday we were talking about organizing qualitative data. So ways we could represent that data, mainly bar graphs, pie charts, and tables showing frequency, relative frequency. Today we're talking about what we can do with quantitative data. And what is quantitative data? Involves numbers. Okay, so let's look at an example. The following data represents the number of available cars in a household based on a random sample of 50 households. Construct frequency and relative frequency distributions. So we could do this on the Chromebook. Let's just do it by hand. It shouldn't take us that long. So the distribution is just that table. So the thing we're looking at would be the number of cars. And then we have the frequency. And the relative frequency. Okay. So it looks like my number of cars we have from 0 up to 5. So frequency is just how many times we get each of those. So let's see, we have 0, 1, 4 zeros. Ones. Are you guys double checking my math here? Or my counting? Twos. 7 threes. 3 fours and a 5. All right, how do we get the relative frequency? These, we should add up to 50. So if you want to check if we didn't miss any. Yeah, adds up to 50. So we just divide those by 50. So 4 over 50, 0, 8. 13 over 50, 0.26. 22 over 50, 0.44. 7 over 50, 0.14. 3 over 50, 0.06. And 1 over 50, 0.02. What should the relative frequencies add up to? 1. Okay. So, pretty similar to what we did yesterday. The difference is this original data is numerical. So we have some other options than just the traditional graphs that we looked at before. One is a histogram. The histogram is very similar to a bar graph. The difference is we have rectangles that are evenly spaced numerically, so they are all going to be the same width. And when you draw them, they're actually touching. Google Sheets does not have a histogram option. It will make our bar graph, but it doesn't make what's considered a true histogram. So I just kind of want to walk you through how we might do one. So this was the data that we just got, and I want to make the histogram. Let's not do both. Let's just do a frequency histogram, because if you could do one, then you could do the other. All right, so we're going to draw this graph to the best of our abilities. When we do that, we need to make sure we are putting labels for the x and y axis. So what would my x-axis be? Number of cars. And then the y-axis would be the frequency. to set this up a little bit different. When we do these histograms, typically we draw a rectangle around whatever x value. So since I need 0 to be one of my options because there was a 0 cars option, I'm going to make my first tick mark 0. And I need to go up to 5. Frequencies, we have anything from 1 to 22. I'm going to count by 2s. So then we make our rectangles. So 0 cars happened 4 times. So what you do is you make a rectangle going around the 0. One car happened 13 times. So these rectangles are touching. Two happened 22 times. Three happened 7 times. Four was 3. And 5 was 1. If I asked for a relative frequency histogram, what would be different? Yeah. It would look exactly the same, but my y-axis label would be relative frequencies instead. Okay, so histogram is just like a bar graph, except all the bars are touching and they go around the number on the x-axis. Sometimes we have too many values. So for instance, if I were wanting to look at how long it took people to finish at the cross-country meet yesterday, would I want to take every individual result and draw a frequency distribution for that? No, there would be so much variety, it would look pretty crazy. Most of the values would just have a frequency of 1. So in that case, it might make more sense to group them together. If you finish between this time and this time, how many people were in that range? How many people were in this range? When we do that, that's using what are called classes. So the classes are any categories we might group data. Numerically, we usually do that when we have continuous data, so an infinite number of answers. We try to group them in classes because it would just not be reasonable to graph every individual result. So let's look at an example where we might do that. The following data represent the time between eruptions in seconds for a random sample of 45 eruptions at the Old Faithful Geyser in Wyoming. Construct a frequency and relative frequency distribution. Okay, so this is just the number of seconds. Could I do every one of these times individually? Yes. Are very many of them repeated? No, so that really wouldn't make much sense. So instead we could group them together. Okay, so I need frequency and relative. Okay, let's look through here. What appears to be our lowest value, so we kind of know where to start those.
672.
672. So we need something that would encompass that. What is the highest one we see? 738. Okay, so my lowest is 672, my highest is 738. So I need to make sure it goes from there. Let's just do, how about I said 670. Now, if I want to go up by tens, I can't say 670 to 680 and the next one 680 to 690. What's wrong with that? Yeah, it repeats. So if I want to go up by 10 each time, where should I end this one? 679. And I could do 680 to 689. 690 to 699. 709. And my last one would be 730 to 739. Something that I should mention on this, the class width, it's the distance from the beginning of one class to the beginning of the next. Okay, so if I look at the example I just did, the class width, how wide our classes are, it's how far is it from the starting of one class to the starting of the next. So what class width did I use? 10, because I started at 670 and the next one started at 680. So that's a distance of 10. A lot of times if I'm asking you to do this, I might tell you, make a frequency distribution with a class width of 5 beginning at this number to kind of help you get started on that, because otherwise you could make a lot of different options and divide them up however. Okay, why don't you guys start, when you figure out how many are in each option. If you're having trouble counting, you could always make tally marks and kind of go through the data that way. But why don't you guys take a minute, let's just divide it up. All right, how many classes do I have up here? Okay, once you guys do 670 to 679, you guys count 680 to 689, 690 to 699, 700 to 709, 710 to 719. You two can do 720 to 729. Izzy 730 to 739. So count how many are in that window. So how many do we have between 670 and 679?
Oh, 2.
Thank you. 680 to 89. We did?
Oh, 3, sorry.
Well,
you were
okay.
wrong too, so.
Between 680 and 689? I didn't think there were any.
Oh my god. We didn't do the one. We didn't do the one with
Okay. This one didn't have any. What about between 690 and 699? 700 to 709. 710 to 719. 720 to 29. And 730 to 39. I had 7. Let's see. I think there would be 7 because we had 45 altogether. Alright, relative frequencies. How do I get those? Mm-hmm. So 2 over 45, 0 over 45. Okay. So I want to make a frequency distribution, but I was going to show you guys how we could use a calculator to do this. So Google Sheets won't make a true histogram, but your graphing calculator will. So everybody needs a graphing calculator. If you have your book, you might look at page 86. So the nice thing about these books, it does tell you how you can do a lot of different things using technology. On the bottom of page 86, it has a technology step-by-step, and it's a blue box, and it tells you for different apps or different programs how to do it. So the TI-8384 is what we have. So it says enter the raw data into L1 by pushing stat edit. Okay, so we need to go into stat, which is under the delete button. We're just going to hit number 1, edit. If you have any information in your lists, okay, this is very important. We will use these lists a lot. You do not want to delete the list button. So don't ever use the delete button. It'll take out the entire list and you won't have a list 1 anymore. And it's kind of a pain to get it back. If there is stuff in here, you could go up on where and have L1 highlighted and hit clear enter, and it will take out every number in that list. So does everyone have a blank list now to start with? Okay. So then we are entering our data in here. There are different ways that we can do this. We could enter all of the original data, and it would actually make the entire thing for us. Why don't we try that? It'll be good. So I want you to go through that original set of 45 numbers. I want you to type all those in, okay? So you go to second, y equals, go into stat plot, highlight on and hit enter. So it's turned on. Now, if you go down to type, this is all the different stuff our calculator can do. It's kind of hard to tell. The first one is just like dots. Second one is lines. The third one is the histogram. So if you highlight that and hit enter. Okay, X list should be automatic. It should be list 1. Remember, list 1 is where we put all of our data. All right, frequency 1, we don't have to worry about that. We're just going to leave that alone. Now, if I just try to graph it right now, it's going to do every individual value. Okay, which a lot of times is fine, but when we set this up, we did classes, right? So I want you to go into Window. Our X-min, when we set up our classes, what was the lowest class? Where did it begin? So my X-min is 670. Enter the max. Where did my last class end? 39. X scale. How wide were our classes? 10. gonna start at 0 because we're just drawing bar graphs, so the lowest would be 0. Y max, we just have to make sure it's higher than the highest value. The highest frequency we had was 11, so maybe I'm gonna go to 15. And then push graph. We should have a beautiful histogram with the class width of 10 plotting all of our data.
Yeah.
What?
Our is not there.
Yes. So I have a mistake on mine that I'm realizing right now. When we did 680 to 689, we didn't have anything. Mine has 1 plotted. That means I mistyped one of my numbers when I was typing it in. So your graph should not match mine because I mistyped a number and I didn't take time to double check. But this is the reason that on test or quiz, you should always double check that you type everything into your list correctly. Yes. All right. Any questions on using the calculator for this? Okay. A histogram is not one that we will do a ton on the calculator, especially not with the classes, but it can be a useful tool just to kind of see how the data is spread out. Let's go ahead and talk about a couple more options. So we could also use a stem and leaf plot. Remember, when you set those up, you have like your stem and the leaf. The stem was the leftmost digit, and the right digit forms a leaf. So for instance, I gave you a set of data and I already made a stem and leaf plot with it. This is unemployment data. Okay, so it gives us for every state the unemployment rate. And then on the next slide, I gave you a stem and leaf plot. Now you notice my original data, 4.7. So on my stem and leaf plot, the 4 would be the left, the 7 would be the right. This one is a little bit different than a traditional stem and leaf plot. This one is called a split stem because there were a lot of values with the same stem. Okay, a lot of 4 point something. And so if you have a really big spread like that, you might want to set it up. So if you look at this stem is basically going to have everything from 3.0 to 3.4. And this one had 3.5 to 3.9. Here we had 4.0 to 4.4. This one is everything from 4.5 to 4.9. So a split stem is just if you have a lot of points with the same stem, you might want to break it up like that. On a stem and leaf, if you have multiple values that are identical, you notice we have 0 4 times. So that meant on my original unemployment data, 4.0 showed up 4 times. So you put repeated values. We also put them in order. So I have all my zeros and my 1s, 2s, 3s, 4s. Okay. You guys have done stem and leaf plots, right? This is something you can do by hand. If you want to do it on Google Sheets, if you like it typed, you're welcome to do that as well. Basically, your stem is a column and your leaf would be the other column. So whatever you prefer. The nice thing of a stem and leaf is that I don't lose my original data. If I wanted to know all 50 unemployment rates again, could I look at this and tell every single number we had?
Yeah.
Yeah, I know I had a 2.8, a 3.2, a 3.2, a 3.2, a 3.3, so forth. But when I looked at that histogram, could I tell you any of the original values? No. So that's the downside of histogram. We don't know the original numbers anymore. Stem and leaf does keep all of those in case we needed them for something else. All right. I already talked about that. Okay, a dot plot. All it does is basically put a dot for each value. Remember, we made a dot plot at the beginning. very first day in stats when we did our dice rolling example, I had you come up and put a dot where for the number you rolled. That's a dot plot. So if I wanted to make those for, let's go back to that car data. All right, so if I wanted to make a dot plot of that. So my x-axis was my number of cars. We had 0, 1, 2, 3, 4, 4, 5 as our options. Then look back, we made a histogram or a frequency distribution of this at the very beginning. So 0 cars showed up how many times? 4. So you put 4 dots. Just one on top of the other. 1 car we had 2 cars, we had 22. How are you feeling about dot plots right now? Anyone else think they're kind of annoying? Three, we had 7. 4, we had 3, and 5, we had 1. So a dot plot, it's kind of annoying making those dots. The benefit of this would be like when we had a lot of people doing something and I wanted to know each of your data, I didn't have to wait and say, okay, how many people rolled 4? And raise your hand and then make a bar graph for it. You guys could all just come up and place your data. But as far as if we have all the numbers, this would probably not be our pick of how to represent it, just because it's kind of annoying to put all your dots on. All right. What do you guys think? I'm close to done. What if I just finish this? Would that be okay? And if I promise a work day to come?
Yeah.
Okay. I'm gonna finish this and we'll decide on when we want to do that. So final thing we're talking about in this is the shape of our data. Uniform is when the frequency is evenly spread out across valued variables. So if I were going to draw a uniform distribution, think about, we've looked at like histograms. So that would be a histogram where everything was identical. Okay, nothing is higher than the other. It's flat all the way across. Bell-shaped is when the highest frequency is the middle and it kind of tails off as we go either direction. Okay, so you see it peaks in the middle, both ends are pretty similar. Skewed right says the tail to the right is longer than the tail to the left. Okay, so skewed right means I have this extending on to the right for a long time. Okay, so it peaks and then I have a lot more values on the right. Skewed to the left means we have more values to the left of the peak. So that would be an example of skewed left. And I did on the next slide, there are pictures representing all of those as well. These terms we will be using the rest of the semester. Anytime we're talking about data, I'll be asking you, okay, is it bell-shaped? Is it skewed left or right? Because that can tell us a lot about our situation. All right, so again, just pictures, uniform, flat all the way across, bell-shaped, sometimes that's called symmetric. You've got your peak in the middle. Both ends are similar. Skewed right, it extends really far to the right. Skewed left extends really far to the left. So final example of the day. So this was our histogram that we got on our calculator. What kind of shape would that be?
Skewed left.
Here's our peak. Okay, but we can see it goes a lot further to the left than it does to the right. So this is skewed left. Alright. So the assignment for this. I'm doing book problems because it's asking us some about the graphs. So let me get your opinion. We have one more section. So we can, my thought is maybe tomorrow I teach section 3 as well. And then give you the homework for that. And then Friday you have a work day to work on both of these assignments. Because it's not going to take you a full class period to do this. So what if I'm not going to collect this until Tuesday. So tomorrow we'll do the last section, have more homework, and then Friday you get the whole class period to work on both of those assignments. Is that fair? Okay. Yes. I will ask, you do have a little time right now if you want to start. When you are done with my calculators today, I need you to turn the stat plot off. To do that, you will go second, y equals, and you see if plot 1 is on, you just go into plot 1 and hit off, and then you can just get out of that second click. Okay, that will reset it so it will work for the next person that comes along.